Suppose there are 120 students in 4 sections, 11 standard in a school. So there are 2 sets. A denote the set of all students class 11. So we'll name these students as A1, A2. There are so many students in the class, isn't it? A1, A3, A4, etc. And set B denote the set of sections. So we have 4 sections, for section 1, second section, section 3, 4 groups. Now define a relation from A to B. The relation is defined as X is related to Y if the student X belongs to the section Y. Now here every student will belong to some section. Every student will belong to some section. They are studying in a school, so they will be in one of the sections. Now can you have one student going to different section? One child will have 2 sections. Is it possible? One child is going to section A and no. So you can have like this, that is student 1 can go to section 1. Student 2 also can go to section 1. Is it a function? How do you say it is a function? Is it a function is the question. Is it a function? When will you say a relation is a function? When will you say a relation is a function? What is the first thing? Every element should have an image. Every element in the set A should have an image. So every child is in any one of the section, isn't it? Nobody will be left out. So every child will be in one of the section. That is the first condition. Second condition, one element should not have 2 images. That means one child cannot have 2 sections. So it is also not possible. So here this is a function. Every student will have a section. Second condition of the function is section is unique. One student cannot have 2 sections. That means every element has an image and it is unique. So it is a function. Every element in A has a unique image in B. Therefore it is a function. Now, is this relation a function? Yes. What can you say about the inverse relation? Now, inverse is the domain. See here, which is a domain? A is the domain. What is A here? The set of students is the domain. Set of students. And what about here? This is the codomain. B is the codomain. Now, when if it is an inverse relation, inverse means the B, the codomain will become the domain. What is B here? The set of sections will become B here, section. See, the codomain and the domain changed. And A will go here. A is the set of students. So we have here 4 sections. 1, 2, 3, 4. There are 4 sections. So A1, A2, A3, A4, A5. One section will have how many students? They can have many students. You can have many students in one section. So is it a function? If you stand in front of a mirror, you can have only one image. You cannot have 2 images. You cannot have 3 images. So this is not a function. Now, every section should have a child. It's not necessary, isn't it? Sometimes what happens, some section may not have also. Some particular group, there won't be any child. That is also possible. So here it's not a function because one section will have different students. Section 1 will have many students. So inverse relation, it is a relation, but inverse relation is not a function. The reason is section 1. Suppose if you take section 1, will have many students, isn't it? That means, what does it mean? An element in B. Element in B. B is the domain now. An element has many images. When an element has many images, see, element 1 has many images, therefore it is not a function. So one element should have only one image. So inverse relation is not a, because one element has many images. So it is not a function. Now next one, write the values of the function f at -4, 1, -2, 7, 0 if this is the function given. The function is given like this. So first let us check where is this minus 4. If you draw the number line, you should know where is this minus 4. 0, minus 1, minus 2, minus 3, minus 4, up 7, etc. So now where is this minus 4? It is minus infinity to minus 3, isn't it? This side is minus infinity, that side goes to plus infinity. So minus infinity to minus 3. First you find in which interval is minus 4. So minus 4 is in this interval, minus infinity to minus 3. Now where is 1? Which interval is 1? Is it in this interval? So you can see less than 1, strictly less than 1. That means 1 is not included. Understood? It is 1 is not included. Here 1 is less than or equal to x, less than 7, that means 1 is included. So 1 belongs to this interval. Now where is minus 2? Third interval. So minus 2 is here. Where is 7? 7. Otherwise, because outside 7 is here. 7 less than 7 is in this interval. 7 and above. 7 is not included here. 7 is included here. So 7 and above is 0. Where is 0? Third interval. So 0 is in this interval. So first you find out, then it will be very easy for you. Now f of minus 4. First one is f of minus 4. So you have to write this function. So it is minus x plus 4. So that is minus of, substitute for x. What is x? Minus 4 plus 4, that is equal to 8. Next is f of 1. Where is 1? 1 is in this. So x minus x square, 1 minus 1 is 0. F of minus 2. Which one will you write for minus 2? X square minus x. So that is minus 2 the whole square minus minus 2. X square minus minus 2. So minus 2 the whole square is 4 plus 2 outside. Now f of 7, 0. Okay. Then you have f of 0. F of 0 is which interval? X square minus x. 0 only. So 0. So 8, 0, 0, 6, 0. Now third sum. So we have to find the interval first. Let us find. Where is minus 3? Which interval is minus 3? First interval. 5. 5 is second interval. 2. Where is 2? Can you see the open bracket? This is called open bracket. When you say, so there are two types of brackets. One is closed bracket. When you say closed bracket, that means 2 is included. You put closed bracket, then 0 here. When I put a closed bracket like this, 0 and 2 are included. If I put 0 and 2 like this, 0 is included, 2 is not included. If I put like this, open bracket for both, 0 and 2 both are excluded. So now tell me where is 2? So otherwise, so minus 3 is in this interval, minus infinity to 0. From minus infinity to 0. Where is 5? 3 to after 3. 5 comes. So that is in this interval. That is correct? Okay. Now where is 2? It is 0 to 2 is 0. That is 0 is not included. 2 is also not included. 0 to 2 is x square. 2 is here. 2 is not there in any group. So 2 comes here. This is open bracket. Here also 2 is not included. Here it is 3 to infinity also 2 is not there. So 2 is in the otherwise because 2 is not there anywhere. See, 2 is open bracket. Open bracket here means 2 is not included. So 2 is here otherwise. Where is minus 1? Minus 1? Minus infinity to 0, you will have minus 1 also, right? From minus infinity to 0, you have minus 1. So minus 1 is also here. Where is 0? Is 0 included here? Can you see this is open bracket? Can you see 0 is not there here? Can you include 0 here? No, because open bracket again, 0 is also excluded from everywhere. Okay, so open bracket they are given. So 0 is also here. So once you know all this, now we can write. So let us first find f of minus 3. So which one will you write? X square plus x minus 5. Minus 3 square plus minus 3 minus 5. Yeah, 9 minus 8, 1. So next is f of 5. Which one will we write for f of 5? F of 5 is x square plus 3x minus 2. That means 5 square plus 3 into 5 minus 2. That means 25 plus 15 minus 2. What is that equal to? 38. Next one, f of 2. So what is f of 2? F of 2 is, which one will you write f of 2? F of 2 is the last one, x square minus 3. X square minus 3, that is 2 square minus 3, that is equal to 1. The next one, f of minus 1. F of minus 1. So f of minus 1 is the first one, x square plus x minus 5. So that is minus 1 the whole square plus minus 1 minus 5. That is 1 minus 1 minus 5. That is equal to minus 5. The last one, f of 0. F of x square minus 3, that is 0 minus 3 is minus 3. State whether the following relations are functions. They are all relations. So you know that every relation is not a function. Remember that. So is it a, if it is not a function, you have to give a reason also. If you are saying it is a function, give a reason. If it is not a function, give a reason. The sets are A only, A to A. The set A to A. It is given, the function is given from A to A. So what is the set A given? A, B, C. Here also the domain, codomain both are same here. In this case both are same. Now they are given here A to C, right? A to C. Is it a function? Every element unique one. See, you should not have one to many. It is a function. Every element has a unique image. It is a function. It is a function. The reason is every element has a unique image. A's image is C. It's a unique image. A is not having two images. A's image is C. It is a unique image. B's image is C. B's image is C. Isn't it? It is a unique image. The image is unique. Therefore, it is a function. Every element has an image. That image is unique for that element. Is it one to one? No. It is many to one. It is a many to one. Why? Two elements have the same image, isn't it? Two different elements have the same image. So, two different elements have the same image. So, it is a many to one function. Is it a onto function? What is an onto function? You have to check the codomain. What is a codomain? Codomain? Set A itself. What is the range? What is the range? BC, are they equal? The codomain is ABC, ABC, and the range is BC. So it is a function, and it is the codomain is not equal to the range, therefore not onto. It is an into function, not onto. Into function. They ask whether it is onto, so you just write not onto, but it is into. So it is many to one into function. The second one is draw the arrow diagram. So they are given here two sets, x only. It is x to x. So x is given as x, y, z. This is also x, y, z. Now look at that. What is given? X to y. X to y. Tell me, x to y. X is going to y, then x is going to z. X is going to z, and This is not a function. Second one is not a function. Why? The reason, give the reason. Y is not mapped. Y doesn't have an element y. Element y belongs to x. Does not have an image. Every element should have an image. So the reason you can write y doesn't have an image. Not only that, one more thing. And also, what is other reason? You can write two reasons here. And x has how many images? You see, x doesn't have a unique image. See, x is having two images. So x has two images. Therefore, it is not a function. Now, question number 5. Let A is 1, 2, 3, 4. B is A, B, C, D. Give a function from A to B for each of the following. So you have two sets here, A and set B. So set A is 1, 2, 3, 4. Set B is A, B, C, D. Now you have to give a function. You can give anything, neither 1 to, it should not be a 1-to-1 function and it should not be on to. You know the definition of 1-to-1. 1-to-1 means different elements should have different images. So it's not 1-to-1 means you can give one element. See, so you can just give one element here, 2 as this, and also you can have one also going like this. See, different elements have the same image. Is it a 1-to-1 function? Why? It is not a 1-to-1 function because 1 and 2 have the, see, they are different elements but they have the same image, isn't it? So it is not a, it is a function, but every element has an image and this image is unique. So it is a function. It is not 1-to-1, not a 1-to-1 function, and it is also not on-to. Why it is not on-to? Why is not on-to? Codomain is not, a codomain is A, B, C, D. The range is A, B, D. So this is not a 1-to-1 function, not an on-to function. So you can write it down here. This is an example for neither 1-to-1 nor on-to. Now second part of the question, it should not be 1-to-1 and it should not be, but it should be on-to. Is it possible? Not possible here. It is not possible because you have equal number of elements. Suppose if you have more elements, then you can write. If you have equal number elements, number of number of elements in A is 4, number of elements in B is also 4. In that case, it is not possible. We cannot write at the same time not 1-to-1 but on-to is not possible. It is not possible. Why? Because number of elements, they are equal. Because number of A is equal to number of B. We cannot find, because once you say, see, when you say not 1-to-1, automatically something will be left out. Not on-to function, right? Similarly, 1-to-1 and third one, is it possible? Again here also it is not possible. It is not possible. Just draw and check. 1-to-1 if you draw, 1-to-1 means it will be automatic because the equal number of elements. So it is not possible here also. Equal number means it will become automatically on-to also. So not possible. Because the number of elements are equal, it is not possible. Now what about the last one? This is easy. 1-to-1 and on-to is very easy. So it is 1-to-1 and on-to. Okay? So what are the elements? Write the elements: 1A, then 2B, 3C, 4D. That's all. It is 1-to-1 and on-to.